Welcome back to the Global AI Student Conference. Our next season is about responsible AI. Our speaker, Luis Beltran, a Microsoft MVP developer technologies and AI, and a PhD student in engineering informatics. Hi, Luis.
He- Hello, good evening, good morning, good afternoon, wherever you are joining. It's a pleasure to be here.
Thank you for being here. So you may share your screen and start your
Yes,
presentation.
yes, of course. So, okay, I'm sharing. Let me know if you can see it.
Yes, we can see it.
Excellent. So, welcome to today's presentation in the Global AI Student Conference about Towards Responsible AI. My name is Luis Beltran. I am a Microsoft MVP in Artificial Intelligence, Azure, and Developer Technologies. I am a Mexican, but currently I am living in Czech Republic because I'm pursuing my PhD at Thomas Vata University in Engineering Informatics. My research topic is actually computer vision, emotion detection, and face recognition. So let's get started with this interesting topic. Actually, last presentation shared several thoughts, and it was really interesting. So it's a good introduction about this topic. So when we talk about AI, we usually refer to a machine learning model that is used within a system to automate something. For example, you might think of a self-driving car that takes images from sensors or using sensors. Then there is a machine learning model that uses these images to make predictions. For example, if an object is detected in the picture, is it a tree? Is it a person? Is it just the road? Then, with these predictions, the car makes decisions. For example, follow the path, turn left to avoid the tree or the person, and so. And the whole system is AI. However, when we develop AI, there might be risks, and maybe what we are developing is unfair or simply seen as a black box that makes decisions for humans, like magic. So we need to know, or we need to think that AI brings unprecedented opportunities to businesses, organizations, but there is a lot of responsibility because it directly impacts people's lives, and it can raise some questions around AI ethics, data governance, trust, and legality. You might see on the screen some research, some some numbers about if people trust in AI. Well, consumers only 35% trust on what organizations offer regarding AI. On the other hand, around 77% of people believe that organizations should be held accountable if they misuse AI. So, well, as you can see, it is quite important to consider some regulation, maybe some steps that organizations should take in order to comply with maybe some rules or just use AI in fair and square way. And that's where responsible AI comes into play. And it involves several actors, data scientists, machine learning engineers, and also, of course, consumers. So what is responsible AI? Maybe we can have a specific definition. So responsible AI is the practice of designing, developing, and deploying AI with good intent in order to empower people, employees, businesses, organizations, and impact customers and society fairly, safely, and ethically in order to build trustness in AI and also scale it more securely. Responsible AI is the product of many decisions made by people who develop and implement machine learning models. From the purpose of the system to the way that people interact with these systems. So the idea is to proactively guide decisions towards more beneficial and equitable outcomes. So people and their goals are the center, the core of the system design. And well, it also promotes some values like fairness, reliability, and transparency. Actually, several companies have developed or believe in some principles of responsible AI. Microsoft is one of them, and they have developed a responsible AI standard, which is a framework for building AI systems according to 6 key principles: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. In this case, Microsoft considers these principles as the foundations of a responsible and trustworthy approach to AI, especially nowadays as intelligent technology is more prevalent and we can see it everywhere in different products. Well, during this World Day, you have seen different applications of AI, interesting discussions, and actually I'm looking forward to one of the upcoming sessions about stable diffusion, so where you can generate interesting images, but well, there are also some ethics behind. So, well, let's talk a bit about some of the principles and maybe see some examples. Okay, so first of all, we have privacy. And yeah, this is one of the interesting topics because, well, I work a lot with computer vision and I use a lot of face data sets. So AI systems like this voice tagging or facial recognition can be used to breach individuals' privacy and threaten security. For example, an individual's online footprint can be used to track, to deduce, or influence someone's preferences or perspectives. And nowadays, it is a serious concern that needs to be addressed. You can see that we might have these deep fakes, which are nice. Let's say that you can swap your face with someone from maybe some famous actor, like there is a movie, there is some video. You can think of your favorite actor, and then you swap your face, and it's as if you were acting on that movie. So this is some, let's say, nice, fun use of AI. However, there is also the fake news. Someone can swap your voice or your, let's say, your face and create a fake video where you talk about someone, where you, let's say, behave bad or just to affect your reputation. Unfortunately, we live in a world where viral videos can be viral, let's say, very quickly, and even though they are fake, the harm is done. So, how to protect our identity? How to verify that whatever is posted on social networks, if it is talking or if it is referring about someone, it is who claims to be for sure. So that's the privacy thing. Privacy is any data that can identify an individual and maybe even their location, activities, and interests. And this is important, especially here in Europe, because of the GDPR and other laws. So you can think of some example. Maybe we have some couple of reports. Imagine that there is some case And we analyze some data, and there are some reports, there are some aggregations. And let's say that we know, or we present, that in our study, 10 participants shared data about location, about salary. The aggregated salary report tells us that the average income of a person from Seattle is some amount, let's say 96,000 US dollars. Then we know from another report that 10% of workers are from Seattle. So we can quickly figure out the specific average salary of the single person from Seattle. So we have, let's say, affected the privacy of this person. So what can we do to protect, let's say, that kind of data? So one solution is differential privacy, which is a technique that, of course, seeks to protect individual data by adding a statistical noise to the analysis process. So basically, this noise ensures that data aggregations stay statistically consistent with the actual data values. But there is some random variation, which makes it impossible to easily figure out the individual values from the aggregated data. So you can observe that now we know that 9.6% of people are from Seattle, so maybe it is not easy to figure out how many people, like numbers, a specific number. And also the average salary, there is some noise, or there is some difference. Now it is not the precise amount that we presented in the previous report, but something that doesn't affect other calculations, that it stays in some range, let's say. And how we can actually implement it in our machine learning models? Well, there are several projects. In this case, there is a Smart Noise, which is an open source project co-developed by Microsoft, which contains some components for building differentially private systems that are global. So the idea is that we add this package, this library, to our analysis, and then the aggregated data contains this noise. We can actually control the level of variation, the noise level, by some parameter known as Epsilon. And well, if we increase, let's say, the Epsilon value, the let's say the noise is less, so there is a reduced privacy. However, the accuracy of the model, machine learning model, is high. On the other hand, if we have low epsilon value, we will get the most privacy at expense of very, let's say, a reduction of accuracy. So it's, of course, some balance between the privacy and also try not to affect at all the accuracy of our models. So we can demonstrate this. Okay, so here I can present, I have Azure Machine Learning Studio, and I will increase this a bit. Okay, so in this case, maybe we have some diabetes data set. And okay, so we install our Smart Noise package. Then we load the data. As you can observe, we have this data set. So there is, let's say, some information about patients, like number of pregnancies, plasma glucose level, body mass index, and all these features in the end determine if some person is or not diabetic. Then maybe we want to protect some specific feature like age, right? So we can observe at the beginning that the average age, this is the average age, is around 30.13 for So that's the average age of all patients. And then if we, let's say, include our smart noise library, we can affect, here you can observe we perform some analysis, statistical noise analysis, and we use differential private mean function, right? And we pass our age column, right? We use epsilon value 0.1, low value, and we can compare that the differential private age, mean age is 30.048, while the actual data is what I said earlier, 30.13. So we see that the value is quite similar, not exactly the same one. So there is the noise. And well, we can also use it for data distribution in histograms. So maybe you cannot see it at all, but there is a minor difference between frequency in different range of, let's say, age. We can also calculate let's say, the covariance, that is the relationship between variables. So the actual covariance, for example, between age and diastolic blood pressure is 8.72, which means that if one value increases, the other one is also affected in the same way. So there is also increase, or they both decrease in the same rate or relationship. And by applying differential privacy, in this case, we apply again DP covariance, the differential private covariance method, we also obtain positive value. So yes, there is still noise involved, but we don't affect our main outcome, which is to find the relationship between these two variables. And well, we can also at the end compare what happens if we use low value and high value of epsilon. In the end, we can add noise, but also affect the accuracy well. So it's about finding some balance. Okay. So well, I presented this already, so you can, if you want, I can share later this notebook. It's fine. You can just send me an email. I will share my contact details at the end. So what's next? Then we have another, or we can talk about another, let's say, principle, in this case, fairness. So the idea is to build models that don't affect negatively people according to some features like gender, age, ethnicity. We don't have to discriminate. So let's say that we are building a model that accepts or rejects, let's say some that people can get money, let's say some loan for something. So the model needs to consider the different variables like age, like income, of course, the amount of loan, but and there will be some decision. It can be positive or it can be negative, but the model must not discriminate, and just because this person belongs to some ethnical group, it will automatically be discarded. So yeah, we should avoid those cases. And well, I can, of course, we can see it on action. So let me show second example, which is about fairness. So in this case, again, we have the diabetes data set, and we want to find, of course, in a model, maybe we want to predict or inform a person if they will develop diabetes or not, according to some characteristics, as we said earlier, like diastolic blood pressure, plasma glucose level, and so on. So let's say, right, that, okay, after running some analysis, we find out that people which are younger than 50 years old, they are not selected to develop diabetes. They are selected just around 30% of, let's say, with success. So, but on the other hand, we have another group, people over 50 years old. They unfortunately develop diabetes over 70%, let's say. So in this case, even though we said, well, this is normal as people grow older, they might develop diabetes. However, there are other features to consider. There are other characteristics. And this model is unfair because maybe some person who is, I don't know, athletic or very healthy, however, they are I don't know, 60 years old, and the model will most probably will tell them that they are that they will develop diabetes because age maybe is a feature more relevant, let's say, for this model. Well, we need to find out some balance to reduce the gap, reduce this huge difference between groups. Okay, so in this case, age is the characteristic, and this is what we can find by using some, let's say, open source packages. In this case, we are using Fairlearn, which was mentioned in the previous presentation, right? And well, this package also by using Azure Machine Learning, we have a dashboard, fairness dashboard, which can get us, let's say, the same information with this dashboard. So I will just go through. I select the characteristic. I select how we measure the performance. So let's say we are considering the recall, and we select some, let's say, error rate, a demographic parity difference. So we can observe that we get these two groups, 50 or younger, they are selected 30% of the time, over 50, around 60 or 70% of the time. So we have detected fairness and how we can mitigate it. Okay, so we can mitigate it by applying some algorithms and also some constraints or restrictions. So we have algorithms like exponential gradient or grid search or even threshold optimizer. The idea is to minimize the difference between groups. And the constraint is what we want to, let's say, what is what we want to measure, what we want to reduce. In this case, it can be the false positive rate parity or true positive rate parity, and so. So, well, we again apply Fairlearn. We generate actually different models, and at the end we will produce, or we will find out, well, according to your constraint, according to some specific algorithm, these are the models. And the best, let's say, models will be found here, where the metric is the highest, let's say closer to 1, and the difference between the groups is small. So, well, we don't have in this quadrant, let's say that, but it's up to us. Okay, what we want to use, either groups with the best recall, so maybe we can select one group from here, or groups with reduced difference among groups, among the characteristics. So for example, here, let's say we selected one of these models, right, from the low part, and you can see that the difference between 50 or younger people and over 50 is now just 5-6%. So the model is more fair than it was before. Of course, maybe the recall is reduced, but again, it's about finding some balance. So, well, I know that we are short of time, so the idea is to consider the other principles. Transparency refers to the fact that, okay, the machine learning model should not be seen as just magic. We need to explain why some decision was made, what characteristics were considered as most important, like, okay, if you are requesting some loan, okay, the decision, okay, it was accepted because of your income, or because of your age, or on the other hand, it was rejected because you were asking for too much. Okay, so yes, it's about finding that, and there are open source packages to explain that. Okay, there is not so much time, so I can share this presentation also later, so you can find why some decisions were made. There is also reliability.
Hey, Luis, just so you know, you
Yes.
can keep going. Our next speaker isn't here, so if you have more to dive into, we are absolutely here to listen to it.
Okay, thank you very much. Thank you very much. And feel free to interrupt me or let me know when I should stop. So, okay, I'm glad. So let's see this example about transparency. So, okay, I'm right. Yeah, it's here. Okay, yes. So we have, again, transparency. The idea is that we want to explain our machine learning models why some decision was made. And well, we are using now Azure ML Explain model, this package. We can use it in our workspace. So the idea is, okay, we create or produce some model. Again, we are using a diabetes data set. Then, why some person was, let's say, detected that they will develop diabetes because of some feature or some data. There are two ways to explain decisions. One is global level and also particular level. So the global level, of course, is about the model in general. The decisions or these characteristics are more relevant. They are more important for, let's say, the results. So there is explain global method, right, that we can use in our training data. So it will find patterns, it will determine which characteristics, for example, in this case, it associates that pregnancies, the number of pregnancies is the most relevant feature for this model. So this one tells or explains why the person develops diabetes. In second level is age, then body mass index, and so. And we can also see, let's say, more or less the contribution in the final result. And we can also, of course, present it with some nice chart. However, then what if we want to know for a specific individual why the decision was made? Because maybe it doesn't agree at all with the global feature, with the global explanation. Then in this case, we have methods explain local, which of course takes a single element, single value, and we can observe, okay, for this individual, for this observation, this person was detected as non-diabetic. Why? Because of the serum insulin level, because of age in second part, and also some other characteristics. So yes, this was the prediction, non-diabetic, and with this, let's say, value 0.33, because in this case, well, yeah, the values are between 0 and 1. 0, non-diabetic, 1, diabetic. So the result was 0.33, which is close, of course, to the class non-diabetic. So yeah, that was, let's say, the final result, and also the corresponding prediction level. Then we might have the same example, but what happens with the other class? Well, support for diabetic, then we see pregnancies, plasma glucose, but the result is the 0.33, but negative. So of course means that this is non-diabetic. So yeah, we can explain or we can justify why the model made some decision. And of course, it's not only about accepting what the AI says, but also considering okay, does it make sense? Or actually our model needs to be fine-tuned or improve, or we need to train it more, maybe, right? So yeah, that's the idea about explaining, and it's not just a black box. Then, well, yeah, for demos, this is all. Then the rest is just talking a bit about reliability. So the idea is that the models are not, let's say, stable. They should be dynamic. They should consider new data. I remember that, well, you might find some famous data sets like the Boston one, which is about house living. However, that data, I think, is from the 70s or 80s. And somehow it was also detected that the data had some bias across some social levels. So, well, the idea is that we need to use new data. Even when the model is in production, the new data, the predictions can be part of new training to improve the level. But we can also ask some questions, right, about the data set. Is the training data considering different groups, and more on that on the next part? Do we need to modify the data to avoid or mitigate bias? Then, did we select just one algorithm, or did we test several of them? Shall we include some constraints, some different arguments, parameters? We can use AutoML. I remember there was
Hey,
a really
Luis.
nice presentation. Hello, yes?
We appreciate you going for so long, and we wish we had time to ask you questions, but could you wrap up in about 2 minutes?
Yes, of course. Okay, so we also have inclusiveness and also accountability. Accountability is related with what we had earlier. Like, okay, there is the automatic car that make decisions. If there is an accident, who is held responsible for these decisions? And also inclusiveness is a bit related with the previous one. So the model should consider, for example, if we are talking about face recognition, they should consider different groups, and in order to avoid some problems, or that some person is not recognized at all. So, well, there are some recommendations which are in according to what we presented. So we need to display contextual information. We need to explain about our models, reduce the bias, explain why the system made some decision correct. The model is not always fine. We need to, of course, improve it, and also encourage feedback. And of course, this will give a lot of benefits. So, well, that's all from me. Thank you very much. If you have any questions, I will do my best to try to answer them.
Awesome. Thank you so much, Luis. We had an absolute blast listening to your presentation. Unfortunately, we don't have time for questions, but hang around in the chat. Maybe we'll have a couple in the audience ask questions. Thank you.
Definitely. So it was a pleasure. Enjoy the rest of the event. Thank you.
Yes, thank you.
Thank you.